Okay, so for our learning outcome, 2.1 is about Bohr atomic model. Okay, we need to describe Bohr atomic model. We need to explain the existence of energy level. Sorry, Fatin, can you please unmute your sound? Thank you. Right. So for C, we want to calculate the energy of electron using this formula, okay, where the RH later Madam will explain what is it and what is the value that you need to memorize. Okay, then we need to describe the formations of line spectrum of hydrogen atom. We need to illustrate the formations of Lyman, Balmer, Paschen, Brackett, and Pfund series. We need to calculate the energy change of an electron during transition. So this is the formula, and this is the constant. Calculate the photon of energy emitted, okay, using the formula given. And then calculate the energy change of an electron during transitions. Again, another new formula. Then we have to calculate the ionization's energy. This one hopefully by the next session. This one will be explained in the next session. So for today, our planning, Madam's planning is to discuss our learning outcome A until H. Right. So I want to know if you have already watched the video that Madam asked you to watch from Miss Balkis.
Yes.
Yes.
So how do you
Yes.
find it?
Yes.
Understand the content?
No,
Yes.
it's too difficult.
Ada yang faham, ada yang tak faham. Mungkin ada banyak terms baru. Okay, ada banyak constant baru. Ada banyak formula baru. So yang ini adalah kita punya chapter 2, which is very different from what you learned before. Okay, so in the video, have already discussed with you the history, where you get the Bohr's atomic models. So basically, from the video, we can sum up 4 postulates. So these 4 postulates you must remember. First, second, third, and fourth. So first postulate, method recap with you together. It is also explained in the video itself. Semua orang kena hafal. Postulate ini macam hypothesis. Okay, hypothesis about this Bohr atomic model. Okay, so our first postulate say that electron moves around the nucleus in a fixed circular orbit. So maksudnya apa yang awak belajar sebelum ini? So contoh, hold on ah. Okay, benda yang awak belajar sebelum ni, kita ada nucleus. Okay, and then surrounding over your nucleus, we have the orbit. Inside the nucleus, we have our proton and also neutron. And then electron move around the orbit. So this is what you learned before as a atomic model. So this is our first postulate. We say that electron move around the nucleus in a fixed orbit. That is the first postulate, the first idea, the first concept. Okay. Then the second postulate say that electron at a certain energy level has certain amount of energy. Or a new words for you, energy is quantized. That means if I focus on the electrons over here, okay, so when this electron is moving around this orbit, okay, at the same energy level, you have a fixed amount of energy. So energy is quantized means it has a fixed amount of energy. So senang nak kata, satu energy level, satu energy. Okay, so dia tak ada gerak mana-mana. So electron memang masih dekat energy level yang sama. Okay, and then after that we have our third postulate, which say that an electron move in an allowed energy state will not absorb or radiate energy. So kalau dekat sini elektron masih dekat orbit yang sama, dia tak akan keluarkan release or absorb energy. So whatever energy we have within that energy level is fixed. So it's still relate to our second postulate. So kalau dia tak bergerak mana-mana, energy tetap sama. So tak ada energy yang diabsorb ataupun radiate. So in another sentence, we can say no energy change when the electron is moving in the same energy level. Okay, so dekat sini awak akan dengar banyak kali Madam mention, okay, orbit. Ataupun ada certain masa awak akan dengar energy level. So it means the same thing. Orbit, okay, energy level is the same meaning. So if let's say we focus on this electron and we say that this is the first energy level. So another one is the second energy level and so on. So orbit memang ada banyak lah, depends kepada berapa energy level yang awak ada. Okay. And then after that, we have our fourth postulate, which say that energy is emitted or absorbed when it change from one energy state to another. So tadi, postulate yang ketiga cakap kalau dia masih dekat orbit yang sama, no release or no absorb of energy. But if you move, okay, electron ini move dia punya energy level keluar ataupun masuk, bila ada transition, okay, your energy will be either emitted or absorbed. So this is our fourth postulate. Keempat postulate ini awak mesti kena tahu dan faham apa cerita dia. So dekat sini, okay, our second postulate and also fourth postulate involve calculation. Is everyone okay?
Yes.
Yes.
So dekat sini Madam lupa nak tanda juga Take notes untuk second postulate and also take notes for the fourth postulate where it will involve some calculation. Okay, so let's just look a little bit more detail into the postulate. What is it about? Okay, so just now we said the second and the fourth postulate. Now we look at the second postulate first. Okay, so second postulate. Hai, Irfan, ambil gitar kenapa? Ambil pen. Sambil Madam cakap awak main gitar pula. Okay, like second postulate ya. I need you to take out a piece of paper and then later when we want to draw something, you can jot down. So second postulate over here is state that the energy of an electron in a stationary state or energy level is quantized. Tadi Madam bagi tahu quantized maksudnya dia ada fixed value. So this is the formula you want to apply when we want to calculate the energy. Okay, so the RH represent your Rybert constant. Okay, Rybert constant 2.18 times 10 to the power of negative 18 joule. So dekat sini unit dia sangat penting. Okay, unit is very important. Why do we say so? Because you have two Rybert constant with different unit, okay, different value. So, kena pastikan awak faham kalau awak nak kira energy, energy adalah dalam unit joule. Therefore, the Rybert constant you need to use is in unit joule. So, yang ini, constant ini, tak payah hafal, tak apa. Awak boleh access daripada sini. So, Madam tunjuk macam mana nak dapat constant. If you go to the my link here, there is a list of atomic mass and constant. So over here, you can see relative atomic masses, and then down at the second page here, you can see. Kita nampak Rybert constant dekat sini. Okay, nampak tak Rybert constant? Lagging sikit Rybert constant, symbol with RH, you have two values. Dekat sini ada dua value. Satu adalah 1.097. Okay, times 10 to the power of 7, which is in unit per meter. The second value is 2.18 times 10 to the power of negative 18 joule. Okay, dekat sini kan kalau awak access, di mana yang ada petak-petak kecil ni adalah negative sign. So you can fill in yourself after you print it out. Okay, so the second value for Rybert constant, okay, is 10 times negative 10 to the power of negative 18. Okay, the differences is the unit. So you see over here, Rybert constant, we have two values, we have two units. So to come back to our contents over here, if you want to calculate the energy of electron, we are using this constant. So the value of n depends. It must be a whole number, 1, 2, 3, etc. Okay, depends what is the questions. Soalan mesti akan bagi tahu elektron ini sekarang dia berada dekat energy level 1 ke, 2 ke, 3. So jawab soalan dekat situ lah. Okay. So n also represent by principal quantum number. We will explain in 2.2. The energy level, stationary state, or the number of particular orbit. So nama yang dia sebut untuk represent n berbeza mengikut soalan. Okay, so if you can see over here in the diagram. Hold on a second. Okay. So do you able to see my diagrams over here? Or is it too small?
Oh, okey je.
Nampak ya semua?
Nampak, madam.
Okay, so for this energy, for this diagram, you can see here inside the center is our nucleus. We know that nucleus is positively charged. Okay, it will attract your electron. So over here you can see N1, N equals to 2, N equals to 3, N equals to 4, which will represent the energy level. Okay, so if we say over here, electron occupies N equals to 4. Okay, so when we want to know what is the energy for the electron at this level, then we apply the formula of this one. So En, N represent the energy level, which in this case is 4. Then we have to substitute the value of N equals to 4. So dekat sini just kira guna awak punya calculator, apply your value for Rybert constant, apply your value for the n, then you will be able to get this value in negative sign. Okay, it means it's close to the nucleus. You are being attracted. Okay, and then the units will be in joule. So mesti kena ingat kalau kita nak kira energy pada energy level yang tertentu, dia mesti ada negative sign. Okay. And then after that, if we want to try it again using another energy level, so let's say over here we say the electron orbiting the nucleus at n equals to 1. Then we apply this formula by substituting the n value equals to 1, and you will be able to get this value. Okay, so if you compare two of this value, you will see that closest to the nucleus, you will have a higher energy value. So kalau awak compare dua-dua value ini, yang E4 ini adalah elektron pada energy level yang keempat. E1 adalah pada energy level yang pertama. So you can see the value. The closest to the nucleus, it experiences stronger forces of attraction. Therefore, the value is slightly higher comparing to the energy at electron at energy level 4. So awak mesti kena faham dia punya scenario. Nucleus positively charged, electron negatively charged. Getting closest to the nucleus, it experiences stronger forces of attraction. Therefore, value is slightly higher. Is everyone okay?
Yes.
Yes, madam.
Any questions so far?
No, madam.
Tidak ada.
Right. So we want to explain a little bit about the ground state you heard in the video, or excited state. So stated over here, ground state is when n equals to 1. Okay, n equals to 1 or any value that is lower. And then the lowest allowed energy state, which is also the most stable one. because it's closest to the nucleus, stronger force of attractions, therefore more stable. Okay, so ini adalah ground state. Of course, dekat sini, value n equals to 1 depends. Sebab nanti kita akan belajar, kita ada beberapa series. So, n equals to 1 is subjected to series. So, setakat ini awak ingatkan daripada point yang kedua. Ground state, dia mesti lowest energy state, most stable, closest to nucleus. Whereas, the excited state represent the energy level which is higher than the value of your ground state. So higher energy than the ground state. Okay, and after you absorbing certain amount, stability of electron decreases because it is further away from your nucleus. So dia punya, what is this called, the name, you need to understand. Ground state closest to nucleus, excited is higher energy level. So, sebelah sini, madam awak lukiskan dalam awak punya nota ke dalam draft paper pun boleh. Okay. So, this is what I want you to practice. So, memang ada paksi. Dekat paksi sini kita akan tulis energy. Okay. This y-axis represent energy, which is in unit joule. Okay. Lepas tu bila awak practice lukiskan awak punya energy level diagram. Madam tulis kat sini dulu ya. Ini adalah energy level diagram. We'll use quite a lot of this, so I introduce you first at this postulate. Okay. So energy level diagram mesti kena ada paksi Y. Okay, tulis kat paksi sini adalah energy with the units of joule. So tadi dalam kita punya model kita nampak orbit-orbit semua tu kan. So kita cuma ambil satu portion sahaja. Satu portion maksudnya dekat sini, let's say I take this portion only. So portion ini madam highlight kan. Transform into your energy level. So says for this one is our n equals to 1. Macam mana madam lukis, awak lukis juga dalam awak punya kertas. So says about this one is our n equals to 1. Okay, this line. Okay, lepas tu line yang kedua, n equals to 2, which is represented by the second line in our energy level diagram. And then after that, our third line, n equals to 3, and then n equals to 4, n equals to 5, n equals to 6, and so on. So kalau further lukis, awak akan nampak n equals to infinity. Tapi dekat sini, Madam hanya tunjuk 6 line sahaja. Okay, 6 energy level. Energy level 1, energy level 2, energy level 3, 4, 5, 6. Okay, so this one also represent the electron. So kalau let's say untuk postulate yang kedua, Madam nak awak kira, okay, the energy for electron at this level. So you need to apply the formula and then calculate. So when we talk about the second postulate, tak ada transition. So dalam awak punya energy level, awak takkan nampak arrow ke, takkan nampak transition. So you will be only applying the formula E, and let's say we want to calculate energy level 1, then you are using this formula. E1 equals to variable constant 1 over 1 square. Kalau nak kira yang kedua, isilah dekat sini E2 and then 2 to the power of 2. So this one is for our second postulate.
Madam, dekat graf tu dia punya garis makin lama makin dekat
Sorry?
Dia punya line N1, N2 tu makin dekat
Yeah. So the line, the gap is getting closer and closer.
Teacher,
Yes?
kenapa R24 R, negative R base 4 tu? Kenapa dia
Ini H, bukan 4. H. Private constant. Dia punya simbol RH. Bukan 4 ya. RH. So ini untuk apply kalau kita nak kira energy untuk energy level yang tertentu sahaja. Ha. Okay. And then let's look at the fourth postulate. Okay, so in our fourth postulate, it says that the energy change, okay, when you make a transition, the electron make transition, the energy will either be emitted or absorbed. Okay, so formula ini adalah untuk awak punya fourth postulate. So the energy changes electron, okay, energy release or energy absorbed, or maybe the question will say energy difference or energy change. So semua ini adalah terminologi yang awak kena faham lah. Okay, energy release, energy absorbed, energy difference, or energy change. It represented by a symbol delta E. Yang tadi punya E sahaja. So delta E equals to your Rybert constant. Okay. In the big bracket over here, we have 1 over Ni square minus 1 over Nf square. Okay. In this one, I will use a slightly different pattern from Miss Balkis. So dalam video Miss Balkis, untuk sesiapa yang sudah tengok, Meda tahu ada yang tak tengok lagi lah. So Miss Balkis dekat sini akan guna N1, N2. Actually, it's the same. It's different just by the symbol only. Whereby I represent initial, or if you want to use 1, 1 represent initial, or F represent final. Okay, so we will use the initial minus and final. Don't forget about the power 2 here. So Rybert constants, again, we use the same thing because delta E is still in unit joule. So kita masih guna Rybert constant 2.18 times 10 to the power negative 18 joule. So over here, delta E is also known as the energy of a photon. We will use two terminology. Either you can see photon or electron. They actually mean the same thing. Photon is an electron carry the energy. So delta E can also be known as energy of a photon, energy release, energy absorbed, energy difference, or energy change. So in this one, if you look at the example over here, electron falls from n equals to 4 to n equals to 1. Okay, whereby N4 is your initial energy level, N1 is your final energy level. So dekat sini awak kena pay attention to the, I would say the grammars, from where to where. So initial adalah 4, final adalah 1. Ataupun saya boleh tukar, soalan boleh tukar. Energy excited from n equals to 1 to n equals to 4. So this one also you need to pay attention. So bila kita cakap N4 higher energy level to N1 lower energy level, this is actually means energy is released. Dekat sini ada tulis. So energy is released. Why we say energy is released? So when you fall from higher energy level to lower energy level, so dekat sini kita fall down, energy is released. So if you look at the Madam bagi contoh kalau kita turun tangga, okay, you're going down from a steps. Okay, so energy will release over here, going down. So let's say electrons over here. Okay, so when you drop from higher energy level to lower energy level, energy will release. So delta E, over here, energy release. So the symbol represent energy release. Your delta E value, you should get a negative value. So kalau kita cakap, okay, yang ini daripada N4 to N1 ya. Higher energy level to lower energy level, energy release. Tapi macam mana kalau kita ada absorption? So electron, let's say dekat sini. Okay, we want to move onto a higher energy level. So says about n equals to 1, we want to move to n equals to 4. You make a transition. So when you want to go upstairs, awak nak naik tangga, perlu energy kan? So energy will be absorbed. Okay, energy will be absorbed. So in this case, when you need energy to excite your electron to higher energy level, so delta E, you will get a positive value. So kita umpama macam dia naik tangga turun tangga, tapi dekat sini adalah energy level. So when you drop from higher energy level or excited state to a ground state, energy is released. So bila energy release kita dapat positive value ke negative value?
Negative.
Energy release we got a negative value. Okay. Tapi kalau kita nak naikkan electron, we want to promote the electron, we want to excite the electron. Okay. From the ground state or lower energy level, okay, excited to a higher energy level, you need to absorb energy. So this value should be in positive value. So ini perbezaan antara absorption dengan emission. Okay, perbezaan absorption, emission. So any question under this part?
Teacher, dia tulis kat sini untuk macam initial, saya tak faham. Initial tu dia kena from n equal to 4 ke n equal to 1, yang mana satu initial?
Okay, so it's tested for your grammar as well lah. From n equals to 4, that means n4 ini adalah awak punya initial. Value 4 ini adalah initial. 2, that means n equals to 1 is your final. So initial, final, mula-mula awak ada kat mana? Okay, so if let's say we look at the examples over here. N4, dekat higher energy level, nak turun kepada N1. So N4 adalah initial, N equals to 1 is your final. Okay, tapi kalau kita tulis macam ni, okay, electron dekat N equals to 1. Okay, and then we want to raise to N equals to 4. So N equals to 1 adalah awak punya initial, N equals to 4 adalah awak punya final. Sesiapa yang nak guna 1, 2, sebenarnya dia sama. I represent initial, 2 represent final. Okay, so a little bit clearer if you want to use the energy level diagram. So madam guna contoh dekat sini untuk energy diagram dekat sini. Tadi yang madam mention adalah electron dekat fixed energy level kan? Ini untuk postulate yang kedua. Okay, if let's say we want to use to discuss the energy change. Okay, says we want to begin with energy absorb. So kalau madam bagi satu scenario n equals to 2 to n equals to 4. Macam mana awak nak gerakkan awak punya elektron? Mula-mula dia dekat mana? So where is your initial electron?
N equal to 2.
N equals to 2. So over here you have your electron. Okay, so this electron from energy level 2 will raise onto energy level 4. Untuk E ni tak payah lukis, ini untuk madam terangkan saja. Awak cuma kena lukis line ni saja. So when you say you see this transition, okay, it represent the electron move from n equals to 2 to n equals to 4. So yang ini naik tangga. Delta E, dia positif ke negatif? Absorption, delta E value positif ke negatif?
Positive.
Positive. Because you need energy to excite the electron. Okay. Tapi kalau madam guna yang ini, kalau like madam say energy level 5 to energy level 2, dari mana ke mana?
Atas ke bawah.
Atas ke bawah, daripada N5, okay, to N1. So bila dia turun tangga, delta E mesti equals to negative value because energy is released. So bila awak nampak transition, madam guna perkataan transition. Maksudnya dia mesti involve dua energy level. Okay, it must involve two energy level. So absorptions from lower to higher, emission, emission yang ini absorption. Yang bawah sini emission. Maksudnya energy is released. Okay, so from higher energy level to lower energy level. So far second postulate and the fourth postulate boleh tak beza di antara dua postulate ini?
Boleh.
Boleh ya. Second, fixed. Okay, fourth postulate you need to involve two energy level. So mesti akan ada transition, either from lower to higher or higher to lower. Setakat ini hanya awak punya idea dengan konsep dengan teori sajalah, kita belum masuk exercise lagi. So for this one, for Rybert constant, right? Tadi madam bagi tahu ada berapa ya value dia?
2.
Yang berbeza adalah
Unit.
unit. Value of course, but the most important thing you need to take notes on the unit. So in here, if we use the equation delta E equals to Rybert constant, and then we have 1 over n initial square minus 1 over n final square. So this one, we will use the Rybert constant of the value of this with a unit of joule. So ini adalah untuk pengkiraan energy. Energy difference ke, energy change ke, release or absorb. Okay, so over here madam juga bagi nota lah, relate delta E of the radiation. Radiation, it means energy ya. Energy absorb, energy change, or whatever. Okay, with two energy level. Ada dua value N. So kita pakai delta E dekat sini. Right, so dekat ini juga relate kepada dua energy level. But what is the subject over here is if you want to find a wavelength. So dekat sini awak ada satu simbol. This symbol we call it as lambda. Lambda. Spelling I don't know. Not sure whether correct or not. Lambda, BD good. Okay. So this lambda represent our wavelength. So normally wavelength, we need to have a unit of meter. So dekat sini, bila awak nak apply formula ini, Rybert constant, you must follow the unit as well. So 1.097 times 10 to the power 7, unit is per meter. Why? Because 1 over lambda, 1 over m. So sebelah kiri ada per meter, sebelah kanan pun per meter juga. So in this case, we need to use this Rybert constant. But I want to remind you about this. If you want to use this formula, the formula on your right, related to wavelength, untuk ni mesti kena tulis dalam awak punya jalan kerja. You must write this along with the formula. Okay, because we are measuring length. Length must always be positive. Okay, value for the length must always greater than 0 or must be positive. So the N2 must be greater than N1. So dekat sini madam tak guna I dengan F. Madam tak guna initial final. Tapi madam guna 1 dengan 2. Kenapa? Kalau dekat sini madam ada value
Madam.
and sorry.
Madam.
Yes. Yes. Any questions?
Madam.
Line dia slow ni.
Kenapa ya?
Line dia slow ni.
Saya tak dapat dengar apa-apa.
Tak dengar apa-apa.
Dengar. Kita orang dengar.
Sekarang dapat tak?
Terus dengar je.
Dengar ya? Okay, tak apa. Siapa yang cakap tadi? Hazim
Saya madam.
Never mind. After the lesson, you can watch back the recording lah. Okay?
Oh, dia tak dengar tapi dia boleh jawab. Macam mana tu?
Tak apa. Mana madam dekat sini? Okay, so hold on Right, so we come back to this equation, this formula. So the two of this formula actually mean the same thing. Cuma dia nak cari apa yang berbeza. So kalau soalan minta awak cari energy change, you use this formula because we are finding the delta E. If the question is asking for wavelength or finding for frequency, then we can use this formula. So remember, 1 over lambda, this wavelength must be in meter. Okay, and then this Rydberg constant, we must use the one with the unit of the length. So yang per meter ini adalah untuk formula ini. So every time when you want to use this formula, you must write together wavelength greater than 0, N2 greater than N1. So tak kisahlah dia absorption ke emission ke, value N2 mesti lagi besar daripada N1. So contoh, if let's say over here I give you N equals to 3 to N equals to, N equals to 6 to N equals to 3. So which one is your N1? Which one is your N2?
6 to N1.
2.
Which one is N1? 3 or 6?
6.
N1.
3.
N1 should be 3. N2 should be 6 because we're using N2 greater than N1.
Oh.
Nampak tak dekat sini?
Nampak,
Madam
nampak.
nak ajar macam mana awak nak bezakan antara dua formula ini So kalau untuk delta E, tadi Madam letak I dengan F. I ini represent your initial energy level. Okay? F ini represent your final energy level. So yang ni penting. Dari mana ke mana yang ni penting untuk delta E formula. But if you want to find 1 over lambda, you want to find the wavelength, tak kisah pun dia naik atas ke turun bawah. Yang penting, value N2 ini mesti lagi besar daripada N1. Because your wavelength should be always positive value. Kalau awak kira tiba-tiba nampak negatif, something is wrong with the wavelength. So you need to recalculate back again. Okay, so Madam nak awak take note juga dekat sini delta E, kita punya value boleh jadi negatif sebab energy release. Okay, delta E boleh juga jadi positif sebab energy absorb. Tapi untuk wavelength, dia mesti lagi besar daripada kosong. Or it must always be a positive value.
Yes.
Do you get it?
Madam, wavelength tu lambda kan? So nanti kalau dah dapat kena
Ya,
macam mana? Kena bahagi satu balik apa? Kena terbalikkan lagi ke macam mana?
Ya, betul. So bila awak kira nanti akan ada example. So for this one, after you calculate, right, you got the values, but it's still per meter. But we know that the wavelength must be in meter. So kita kena
One bagi jawapan.
jawapan. Satu bagi dengan jawapan yang awak dapat untuk dapat wavelength. It's a very good question. Thank you, Ajay. Alright, so just to not memorize lah, to understand when to use these two formula. Okay, so yang penting macam mana nak apply konsep semua ada dalam video. So dekat sini Madam nak summarizekan awak punya formula. Okay, so this is a few formula that we are going to use in our 2.1 calculation. So to recall back, the first formula awak guna bila first formula untuk postulate yang keberapa? 1, 2, 3, 4.
2.
Kedua. Okay, this is our second postulate. So to calculate the energy of an electron at specific energy level. So kalau awak nampak dalam soalan hanya mention satu energy level saja, so that represent this energy level. And then the second one represent our fourth postulate whereby electron make transition. Lower to higher, higher to lower, either way. Okay, so delta E, to calculate the energy emitted or energy absorbed, which involve two energy level. Okay, so for your third formula, 1 over lambda, in this case, this Rybert constant is different. So dekat sini bolehlah catat dalam awak punya nota sendiri. Rybert constant yang kita guna untuk 1 over lambda is 1.097 times 10 to the power of 7 per meter. Okay, so in this case, very important that you take notes. N2 must always greater than N1. Doesn't matter going up or going down. Okay, because wavelength must be always greater than 0. The fourth formula, delta E equals to H nu. Madam nak tahu mu ini maksudnya apa?
Frequency.
Frequency. Dalam video pun ada, so madam tak repeats again. Just to remind you again, delta E energy change, and then this H will represent your Planck constant. Okay, Planck's constant. And the values equals to 6.6256 times 10 to the power of negative 34 joule second. Madam, perlu hafal tak yang ni? Again, the same thing. You can refer to the list over here. And in the list, you can see over here. Just on top of Rybert constant, we have the Planck's constant, will represent by the H value. So dekat sini untuk Planck constant pun ada dua. Kita guna yang pertama saja. Value dia sama cuma unit. You need to alert with the units. So 6.6256 10 to the power of negative 34. Dalam petak kecil-kecil ni nampak petak ni kan? Sebenarnya adalah untuk simbol negative sign. So 10 to the power of negative 34 joule second. Okay. So delta E equals to H nu, which is also equals to H C over lambda. So in this case, nu equals to C over lambda. Nu is frequency, C is speed of light, and then the lambda is your wavelength. So mesti ingat wavelength dalam meter. Tak kisahlah soalan bagi awak nanometer ke, micrometer ke, sentimeter ke, awak mesti kena convert dalam meter. Sama juga untuk yang ni. This lambda should be in meter. Kalau soalan minta nano, awak kira dulu nanti baru buat conversion. Okay, so this lambda in meter, this lambda also will be in meter. So this is the 5 formula that you can apply when you're doing calculation. So let's look at the examples. So examples ini madam nak awak kira sama-sama atas awak punya kertas. Okay, so make sure every time you write down something, right, this paper or your notebooks, you keep it properly.
Madam,
Yes.
yang ni notes ni dapat dari mana? Sebab saya punya macam lain daripada yang madam tunjuk ni.
Daripada my link?
Sebab saya punya macam beza lah. Ke yang ni yang lama punya?
Tak, sama je. Yang lain dapat tak? Madam access daripada sini, my note. Okay, when you go into your my notes, you will see there is 7 folder, represent 7 chapters. So ini adalah chapter yang kedua. So dalam chapter yang kedua ada nota. So ini 2.1. Yang lain dapat nota yang sama tak?
Dapat.
Sama ya.
Dapat.
Okay.
Ada.
Alright. Let's try our first questions together. So which formula you want to apply?
Formula number 1.
Formula number 1. Number 1 tu ialah apa? Determine energy of an electron energy level n equals to 5. So kita nak
E5.
Negative, don't forget, Rybert constant, 1 over
over
n
n square.
square. So this one is the energy quantized for this level only. The meaning of quantized is specific. So apply awak punya value Rybert constant, apply awak punya value n, and I want to check your answer also.
Madam, ni question 2 kan? Kita bincang sekarang ni.
Question 2. Untuk first part, madam hanya ada 4 soalan saja ni, soalan yang pertama. Okay, see whether you got this value or not. And don't forget the unit for energy is in joule. Is everyone okay?
Yes.
Okay, madam.
Dapat?
Dapat.
Okay, ni RH dia guna yang apa ni? Yang
RH guna yang
2.18
mana satu? Kenapa
2.18.
nak guna 2.18?
sebab dia cari energi.
Dia nak cari energy, so we use this Rybert constant 10 to the power of negative 18. Ataupun kalau nak cari delta E pun guna Rybert constant yang ini sebab unit dia dalam joule. So 1 over 5 square. Okay. So the second question, calculate the energy of photon A of a radiation with a frequency 8.5 times 10 to the power of 14 hertz. So frequency with a symbol nu. Dia nampak macam satu V tapi ada curvy sikit dekat atas ni. So which formula you want to apply for this?
The fourth formula.
Which is?
Delta E equals to H mu.
Yes, delta E equals to H mu. So Planck constant, just now Madam have already mentioned, if you want to reassess can, ataupun Madam bagi terus, dia punya constant value. So 6.6256 10 to the power of negative 34. Ingat yang ini ada negative sign. And then your frequency, you just take straight away from the questions. Hertz also means per second. So kalau dekat sini kita tahu Planck constant ada unit dia adalah joule second. So ini per second kita boleh cancel off. So final answer you will get in joule. So 8.5 times 10 to the power of 14 to get your answer 2.74 10 to the power of 16 joule.
Madam,
Yes?
yang simbol yang macam V tu, dia punya nilai dia pun dapat juga daripada table juga kan?
Ini, simbol mu ini.
Ya. Yang mu
Tak,
tu
simbol
pun
mu ini dia bukan constant. Frekuensi bukan constant. Dia ikut soalan dan dia ikut foton yang berbeza.
okey, baik.
Yang constant dekat chapter ini hanya Planck constant dengan Rybert constant. Okay? So can everyone follow until question 2?
Yes.
Yes.
Madam,
Okay, yes.
I don't understand. Saya tak dapat jawapan dia.
Mana satu? Dua ke satu?
Jawapan tu saya tak dapat, mungkin saya tak faham. Ada kena tukar unit ke?
Untuk soalan kedua ke pertama?
Kedua.
Kedua tak payah. Terus tekan calculator saja.
Saya tekan dapat 5.6 something.
5.6 something. Let me check again.
Power of negative 19.
Hold on ah. Maybe madam salah kira jugalah. Hold on ya. That's why I ask you to always check with me. Ada masa madam terus kira. Okay, you got 5.63 10 to the power of negative 19.
Yes.
Yes.
Okay,
Yes.
thank you very much. 5.63 10 to the power of negative 19. Sorry, yeah, my mistake. Is everyone agree with this answer? 5.63 10 to the power of negative 19.
Yes.
Agree, yeah. Thank you very much. So delta E equals to h nu. So you calculate, you will get this answer. Don't forget about your unit as well. Then we look at the question number 3. There is some corrections for question number 3. Okay, I just want to ask if anyone know what is the problem? What is the problem in these questions? Calculate the energy release of a photon when you make a transitions from n equals to 2 to n equals to 5. Ada sesiapa tahu soalan ini kat mana ada masalah?
Energy absorb.
Punya
Release.
Kenapa
Release.
energy release salah?
patutnya release daripada
Daripada
kecil.
absorb.
Sebab daripada N2 lower energy state to
N2 to N5.
higher energy state. So dari lower ke higher, kalau kita lukis dekat sini. Okay, N equals to 2, moving to N equals to 5. Naik ke atas maksudnya we need energy. We need to absorb. So over here is the energy absorb. Tolong tukar soalan. Energy absorb. So remember, if we talk about energy change, energy differences, you need to look at the initial and final. Mesti kena identify siapa initial, siapa final. Baru akan nampak, okay, final value is it in positive sign or negative sign? So kalau energy absorb, what is the sign or the value you will get? Positive or negative? Kalau memang daripada N2 pergi N5, you akan dapat positive value ke
Positive.
negative? Positive.
Positive.
So bila awak dapat negative, something is wrong over there. Okay, so please change the words over here. Energy absorb. So dekat sini N initial ialah apa?
2.
2 ke 5?
2.
N final adalah
5.
Okay, so we are using the formula which represent your fourth postulate, delta E, Rybak constant, then N initial square, and final square. If you want to use 1 or 2, up to you, that's fine also. Initial represent 1, final represent 2. So apply awak punya calculation. So we're still using the Rybak constant in unit joule, 2.18 times 10 to the power of negative 18.
Madam, soalan ni jawapan dia positif, tak payah tulis lah positif tu kat depan. Biarkan kosong pun tak apa
Biar kosong tak ada masalah. Tapi kalau ada negatif boleh tulis. But encourage to write positive lah so that your alert energy is absorbed. Kita tulis je lah. Tapi kalau dia tak ada memang maksudnya energy absorb ya. Do you agree with the answer over here?
Yes.
We check together. Sometimes madam make mistakes. You need to let me know. So we have the delta E positive value 4.578 10 to the power of negative 19 joule, which means energy is absorbed when you make a transition from lower energy level to higher energy level. Shall we proceed to question number 4?
Yes, madam.
Okay. There will be some further questions after the second part of the topic, yeah? So for this part, we only try 4 questions first, and then after that, we have some more questions. Okay, right. So question number 4, determine the wavelength in nm. This nm means nanometer, okay, of a photon absorbed by hydrogen atom when it was excited from n equals to 3 to n equals to 6. So this wavelength, we have a symbol lambda. Okay, it must be in nanometer for your final answer. Okay, so you have n equals to 3, n is equals to 6. So which formula are we going to use?
Formula yang ada lambda tu.
Yang mana satu formula dia boleh kita dapat cari lambda, pada masa yang sama
Three.
dia ada 2 n value.
1 over lambda equals to Rybert constant. 1 over n square I minus 1 over n square final.
Thank you very much. So we have 1 over lambda formula. Okay, so 1 over lambda equals to Rybert constant 1 over n1 square minus 1 over n2 square, whereby the value of lambda should be more than 0. Okay, n2 should always greater than n1. Maksud madam tadi, dua benda ni mesti tulis sekali dengan formula awak. This is the requirement if you involve in the writing exam. This two is the requirement. Kalau awak tulis formula ni saja tambah dua benda ni, maka formula ni tak ada markah. Delta E tak ada masalah. Delta E no problem. But 1 over lambda, this is a requirement, a must requirement for you. So in this case, can I know what is your value 2? What is your value 1? You have 2 numbers over here, right? And 2 equals to 6. And 1 equals to
1 is equal 3.
3. So over here, 1 or 2, I'm not suggesting to use initial final here. Sebab kita cuma nak tahu value mana satu yang lagi besar, mana satu lagi kecil. So final initial is not appropriate in this case. Okay, so you just apply your values over here. What is the Rybert constant we are going to use in this case? Are we still using 2.18?
No.
No, we are using
No.
1.097.
1.097.
Yes. Times 10 to the power of 7. So since we have already determined who is number 2, who is number 1, then we just fill in accordingly. So n1 square, which n1 is 3. So 3 square minus 6 square, because n2 is valued 6. Okay, what is the value you got in this case? We want the values here first before lambda. Sebelum lambda. Dapat berapa?
914166.67 per meter.
Is everyone agree?
Yes.
Why per meter? With this unit per meter is getting from your Rybert constant. Jangan lupa Rabbit constant punya unit adalah per meter. So dekat sini masih lagi per meter. Kita belum lagi jawab soalan. You still halfway there. So in order to get your wavelength, we need to convert into meter. So if you see 1 over lambda, so we want to convert into lambda 1 over the answer that you got earlier here. But still, we are finding the answer in meter. So cari dulu jawapan ini. 1.0
94.
94.
power
-6.
-6. So now the question is, we want to answer or give your final value in terms of nanometer. So macam mana kita nak tukar kepada nanometer? How?
Divide by
-9.
Divide by
1 times 10 to the power of -9.
-9. So yang ini Madam rasa you all ada hafal sebelum ni kan? Tera, giga, mega, kilo, hektar, deka semua ini ada pernah hafal kan?
Yes.
So kalau nanometer maksud dia adalah 1 darab 10 to the power of -9 meter. So we need to divide by 1 times 10 to the power of -9, which gives us the value 1093 nanometer. 0.9 lah. Do you agree with this? Do you agree with this?
Yes.
Yes.
Medium, can I ask? Kalau kita tak show nilai 1 over lambda tu dulu, kita macam terus buat terus dapat lambda, kita inversekan jawapan tu. Tak show.
Boleh. Yang ini tak tulis boleh. Asalkan awak tunjuk yang dalam meter dulu sebelum awak tunjuk nanometer. So this conversion you need to show. You cannot stray away from this answer and then you give lambda equals to 109 3.9. Yang ini tak boleh lah. Kalau step ini awak nak terus kira boleh. Tapi bagi dulu dalam meter dulu, sebelum awak convert.
Okay, Madam.
Right. So can everyone follow up until this part?
Yes, madam.
Boleh, madam.
Okay. So if you have done, we want to proceed to the second part of 2.1. Hold on, yeah. Okay. So 2.1, still we have already discussed about first, second, third, and fourth postulate. The next thing you want to look is the spectrum. Okay, you need to understand the word spectrum. So it refers to a range of electromagnetic radiation, okay, with respect to specific wavelength or frequency. So there are two spectrum that you can see, or it is exists naturally, which is our continuous spectrum. Okay, the very easy example, if you can see rainbow. Rainbow is called a continuous spectrum, where there is no specific line to differentiate between red color, orange color, yellow color. So it is continuous. Okay, but light spectrum, another spectrum, is a spectrum of radiations that consists of discrete line or specific line or separate line of specific wavelength. So when we say about light spectrum, every single line or every single radiation, it has their own specific wavelength and frequency. Okay, so example, and also what we are going to learn now is our hydrogen spectrum. Okay, there are two light spectrum which refer to emission and also absorption spectrum. So sama juga apa yang kita discuss tadi. Absorption spectrum, that means electrons moving from lower energy level to higher energy level. If you say emission spectrum, that means electrons moving from higher to lower energy level. So dua-dua perkataan ni awak pun kena alert, emission dengan absorption. Okay, so let's look at the specific example of hydrogen spectrum. So our hydrogen spectrum, again same thing, consists of discrete line of specific wavelength. Perkataan discrete kalau tak faham, kita boleh guna word separate lines or individuals line or specific lines. So containing the specific wavelength. So setiap satu line, wavelength dia berbeza, frekuensi berbeza ataupun delta E pun berbeza. Ikut formula lah. So a line is formed when an electron drops from higher level to lower level. Okay, the discrete line reflects that energy is quantized. So setiap satu line, madam highlightkan perkataan line ini, maksudnya energy adalah quantized. Energy adalah specific. Okay, so this one, something you have seen before, if you're using a prism, right, you can see a rainbow color. So how actually this line spectrum is formed? So we want to see, or we want to tell a story about the formations of line spectrum. So yang ini pun awak kena hafal juga proses dia. Okay, so emission spectrum, emission adalah daripada higher energy level to lower energy level. So we will say from the very beginning until the end. Okay, so energy is first supplied inside your discharge tube. So this is where it happened. Okay, energy is supplied. An electron absorb the energy and excited to higher energy level. So madam rasa madam kena describe guna ni jugalah. Ordernya. So for this one also you can practice on your own on how to draw an energy level diagram. So let's say I only use 3 energy level here. So it says that, so when the energy is supplied to a hydrogen gas in the discharge tube, the electron of the hydrogen atom absorb the energy as being excited to higher energy level. So mungkin dia dari bawah, dia nak pergi kepada higher energy level. Okay, and then at this higher energy level, it become unstable. So at excited state, electrons are unstable. Then it will fall down to a lower energy level. So kalau dia excited sampai n equals to 3, let's say. Dekat sini madam show 3 energy level saja. So bila dekat energy level 3, the higher energy level, it becomes unstable and it fall down. Okay, to a lower energy level. So when it fall down over here, energy is released. Okay, energy is released. So now the electrons over here. The electron is at energy level 1. Then when the energy is emitted, you actually giving out radiation. So energy emitted sama dengan radiation. So you are producing one spectrum. So when it fall down, energy emitted or radiation emitted, then you are forming one line. So ini adalah kita punya light spectrum. Dekat diagram seterusnya nanti akan ada. Okay, so dekat sini awak kena faham lah proses dia. Excited dulu, lepas tu jadi unstable, lepas tu dia fall down, baru akan dapat line spectrum. So this is a story you need to understand. So every single line in the line spectrum, they have their own specific wavelength. So proses ini kalau awak tak faham, kena repeat beberapa kali lah sebab teori dia memang ada proses dia tersendiri. So let's just look at the specific examples further. Hold on, yeah. Okay, we talk about this one first. So energy level diagram for a hydrogen atom. Tadi yang madam lukis hanya satu line saja ataupun satu transition saja. Tapi sebenarnya dalam awak punya energy diagram, it differentiate into different series. Okay, kenapa kita cakap different series? Let's look at the ground state. So if you remember earlier just now I said n is not always equals to 1. Or it depends what is the series you have or in the questions. So the transitions of electrons that result in the formations of Lyman, Balmer, Paschen, bracket or P-fan can be shown by using the energy level diagram. So dekat sini awak nampak banyak transition. Okay, so for each transition over here is contained inside different series. Maksud series dia lah apa? Kalau awak tengok nama dekat bawah sini kita ada Lymans. So when we say about Lymans, every single transition, it falls down to energy levels 1. Okay, so setiap satu transition kalau dia patah balik kepada energy level 1, it means it is inside Lyman series. It can be from 2 to 1, 3 to 1, 4 to 1, and etc. Tapi janji final energy level adalah N1. So dekat sini, Lyman, the N2, the final energy level is 1. The higher can be 2, 3, 4, or etc. Okay, and then if you look at the second series over here, we have our Bohr'S. When the transitions make from energy level 3 to 2, 4 to 2, 5 to 2, and etc. So this represents a Bohr'S series. So Bohr'S series, the ground state is energy level 2. So higher energy level can be 3 or 4 or 5 or etc. So sama jugalah kalau madam guna warna yang lain energy level 3 maksudnya dia ialah Paschen. So every single transition fall down to ground state 3. That represent Paschen. Okay, kalau untuk 4 bracket, untuk 5 adalah P-fan. Is everyone alright with this series?
Yes, madam.
Boleh faham ya?
Madam, ni kena hafal ke?
Ya, kena hafal. Lyman, Balmer, Paschen, bracket, P-fan. Dan juga region dia pun awak kena hafal. Lyman, ground level yang pertama ini adalah dalam region ultraviolet, we say UV. And then the second series, the Bohr'S, is very popular. Madam bulatkan dekat sini. Kalau kita cakap Bohr'S series ataupun ground energy level 2, it is within visible region. So when I say I can see the light spectrum producing color lines. Kalau dekat sini, kalau madam hasilkan satu line spectrum yang dia ada line. Line pertama warna merah. Line kedua warna hijau. Line yang ketiga warna biru. Line yang keempat warna purple. So when you can see this color, it's actually under visible region. It represent Bohr'S series. Ini adalah clue Kalau nampak warna, sekarang awak nampak warna ini hijau kan? Ini pink color, ini blue color. Sebenarnya semua benda ni berada dekat Bohr'S series visible region. Do you get it?
So we need with the help of prism to observe the color, right?
Sorry?
Can we observe the color with naked eyes or we need the help of prism?
No, just naked eye. So
okay.
sekarang ni awak nampak kan warna merah, ni warna pink, ni warna biru, ni warna purple, semua nampak. Semua ini adalah dekat visible region. So ini adalah salah satu clue yang sangat penting lah. When you see colours, Bohr'S. Ground energy level 2. So untuk table ini kena hafal. Kalau madam bagi tahu ground energy level 5, itu adalah series P-fan. Tapi semua series ini adalah untuk hydrogen atom saja. Okay, so madam testing guna table ini. Kalau madam cakap, okay, when the transitions is made of an electron from energy level 6 to energy level 3, what is the series? What is the series? Energy level 6 to energy level 3.
Touchen.
Touchen. So if I said there is a transition from energy level 8 to energy level 5,
P5.
P5.
P5. So you look at the N2. Where does the electron fall? Then it represents which series. So kalau soalan tanya region, so awak ikutlah. Kalau P5 dia adalah dekat infrared. Kalau Bohr'S dia adalah dekat visible. So everything is stated inside this table. Okay, so let's look at how are we going to produce line spectrum, which is represented by this diagram. Okay, diagram ini adalah apa yang Madam lukis tadi. Nah, you punya energy level diagram, this one. So we have our y-axis represent energy in joule. We have energy level 2, 3, 4, 5. Dekat bawah sekali ada energy level 1 kan. Tapi untuk series ini adalah Bohr'S. Sebab tu dia henti kat energy level 2 sahaja. So you can see over here, if I close up this one, by referring to this energy level, you can see, there is 3 to 2 transition. 3 to 2, 4 to 2, 5 to 2, 6 to 2. So every transition stop at energy level 2. You know that it is Bohr'S series. Okay, so Madam highlight dekat sini lah. When colors are observed, so color observed dekat line spectrum sini. So let's say I write something down here. This diagram is your energy level diagram. Okay, the bottom one is your line spectrum. So ada beberapa perkataan yang awak kena alert So energy level diagram with the axis and then line spectrum looks something like this. So when color are observed, color observed dekat sini lah, dia represent visible region. It also represent your Bohr'S series. It also tells you that the ground energy is n equals to 2. Okay. So if you want to draw the line spectrum, it must first come from your energy level. So let's say over here we have N3 mega transitions to n equals to 2. And then this one producing your first line. Macam mana kita cakap first line? First line is from the one energy level higher. So yang dekat sini ground state adalah 2. So satu energy lagi tinggi adalah 3. So 3 to 2 is our first line. Then our second line will be 4 to 2. So this is the line produced from the transition. So kalau daripada 3 elektron turun ke ground state 2, so ini adalah line yang pertama yang awak wujudkan. Okay, first line, which is from transition n equals to 3, 4 down to n equals to 2. So the first line formed in Bohr'S series, when electron falls from n equals to 3 to n equals to 2, it also shows the longest wavelength. Macam mana kita tahu longest wavelength? Awak tengok pada sini. Pada tempat yang Madam highlight ya. Okay, you look at the first line over here. Okay, this delta E is the smallest. Okay, we have the smallest value for the energy difference. So according to the equation, the smallest the differences in energy, the longest is the wavelength. Sebab kalau awak tengok pada formula, delta E equals to hc over lambda. So if you have the smaller value for differences energy or energy release, you have the longest wavelength. So we say that the first line in every series, you have the lowest or smallest delta E, you have the longest wavelength, you have the lowest frequency. Kenapa lowest frequency? Sama juga kalau kita apply formula. Delta E equals to h mu. If for the first line, delta E is the smallest, therefore frequency will be the smallest or the lowest. So relationship antara awak punya delta E, lambda, frequency, you need to take notes. Okay. So until this part, any questions?
No, madam.
Okay, so repeat sekali lagi kalau untuk first line in Bohr'S series, the electron falls from 3 to 2, creating a first line. How about the second line? Line yang kedua awak buat
4 to
transition
3.
dari mana ke mana? Dari 4 ke
2.
2. So setiap kali kalau awak ada line spectra, awak boleh tulis ke atas. So line yang kedua, madam tulis kat sini n equals to 4 falls to n equals to 2. That is for the second line. Second line dekat sini. Kalau untuk third line, awak akan nampak first line, the wavelength is longest. So awak akan nampak dia punya jarak besar. So makin jauh, the transitions, the line is getting closer and closer. Okay, so for the second line, closer because wavelength is become smaller, shorter. Okay, the third line also getting closer because your wavelength is getting smaller. Okay, then the fourth line getting smaller again. So awak akan nampak line spectrum awak akan ada jarak sama macam energy level juga. So the third line, the blue line over here, it falls from energy level 5, okay, energy level 5 to energy level 2. This form the third line in Bohr'S series. How about the fourth line? Line yang keempat dari mana ke mana?
From 5 to 2.
6 to 2.
From 6.
6 to 2. Sebab first line daripada 3 ke 2. So second 4 to 2, the third 5 to 2, then the fourth line will be from 6 to 2. So kalau madam ambil contoh untuk yang line yang keempat ini, okay. So we can say over here the fourth line, if you only got 4 line here lah, it has the highest difference energy. So highest or greater delta E. At the same time, when you have higher energy difference, you will have the highest frequency, and therefore you will have a shorter wavelength. Sebab dia inversely proportional. Kalau delta E besar, wavelength dia kecil. So you have the shortest wavelength in this case. So if you want to compare between the first line and the last line in this diagram, first line, lowest delta E, lowest frequency, longest wavelength. The last line in this series, in this diagram given, you have the shortest wavelength, highest delta E, highest frequency. So kita boleh dapat dia punya comparison daripada diagram, daripada line spectrum. Okay, so we madam show one examples over here. If you have any questions, you may ask. Hold on, yeah. Kejap madam Bina. OneNote tak jalan. Okay, so let's look at the example questions here. Okay. Daripada line spectrum dekat sini, boleh tak siapa bagi tahu madam, first line ialah A, B, C, D or E?
E.
A.
Line E first.
A.
E.
A.
Sebab paling panjang.
Sebab line spectrumnya awak kena faham dia punya wavelength menunjuk dekat sini. So you can see from this line spectrum kan, semakin pergi ke arah kiri, your wavelength decreases. Boleh tak nampak dia makin dekat? So wavelength decreases. So just now we say the first line always has the longest wavelength. Kita kena lukis balik sekali lagi. Okay, so I think I need to prepare this one next time. So over here we have, tell me about Paschen series. What is your ground state?
3.
N equals to 3.
3.
Okay, so ground state N equals to 3. So our first line, it falls for energy 4 to energy level 3. So that one is your first line, isn't it?
Yes.
Okay.
Yes.
So kalau macam biasa, macam tadi yang kita tunjuk dalam diagram kan. Hold on. So line spectrum dia akan nampak macam ni. So let's say I use a different color ya. Your first line. So dekat sini. Ini adalah line yang pertama. First line. Okay. Kalau kita buat transition yang kedua. Okay. The second transitions flow from energy level 5 to energy level 3. Yang ini second line kan. So dia punya jarak dah makin dekat. Tapi tak nampak kan sebab dua line je. So kita buat satu line lagi. So let's say over here we have from our energy level 6 to energy level 5. Sorry. Aduh. Tambah lagi satu line kat atas sini ya. Okay, so let's say this one is our energy level 6. So from 6 to 3 is which line? Is our third line, isn't it?
Third line.
Okay, so third line
Yes.
dekat sini, dia punya jarak akan makin dekat. Kalau kita ada fourth line, fifth line, sixth line, you will see over here is getting closer and closer because the wavelength decreases with increasing delta E. So dekat sini Madam buat contoh Ini adalah delta E awak yang pertama. So if you apply the formula, the smallest the delta E, the longest the wavelength. Comparing to the third transition, okay, delta E is bigger. Therefore, it represents a shorter wavelength. So kalau dekat sini awak akan nampak semakin a biggest gap, the lines over here is getting closer and closer. So this one represents your second line, your third line, your fourth line, fifth line and so on. Tapi dekat sini apa beza dia? What's the differences between two of these diagrams? Dia cuma terbalikkan awak punya diagram. Nampak tak? Tadi kita cerita ini adalah first line. Tapi dia punya wavelength jadi makin kecil. Okay? The wavelength becomes shorter and shorter. So you need to identify, starting from where first? Which one is your first line? So the biggest wavelength or the longest wavelength represent your first line. Then for B, it will be second because it's getting closer. And C is the third line. D is the fourth. E is the fifth. Do you get me over here?
Yes, madam.
Yes, madam.
Boleh faham ya?
Boleh.
Boleh.
So, madam nak tanya juga daripada line spectrum ini, first line is from which energy level to which energy level?
4 to 3.
4 to 3.
4 to 3.
3. So, awak boleh tulis juga dalam awak punya diagram. From energy level N equals to 4 to N equals to 3. How about the second line?
5 to 3.
5 to 3, the third line?
6 to 3.
6 to 3. How about line D?
7 to 3.
And the last one?
8 to 3.
Okay, yang lain boleh faham ikut yang ini?
Boleh.
Faham.
Okay, so let's look at the questions. Which of the line in Paschen series correspond to the longest wavelength? A, B, C, or D?
A.
A.
A, because it is the first line and because it has the smallest delta E. Okay, boleh catat line A in Paschen series correspond to the longest wavelength. Dalam jawapan nota pun ada kan? Line A, because the delta E is the smallest, or you can just write down the formula. Smallest energy is different, longest wavelength. Nak tulis dalam ayat boleh, catat macam ni pun boleh, asalkan awak faham. Smallest delta E, longest wavelength. That is the reason lah. Smallest or lowest delta E, and then you have the longest wavelength. So line A lah for your part A answer. Okay, and then actually the second questions over here written here is, Madam forgot to write down. It's actually want you to write A. Describe the transitions that give rise to line A. So as discussed just now, in order to form our line A, which is the first line, you need to form when electron make a transitions from n equals to 4 to n equals to 2. So dalam jawapan pun Madam sudah bagi. So describe dalam satu ayat yang pendek boleh ceritakan lah. When an electron makes a transition. Bila awak ada perkataan makes a transition, you know it involves two energy level. Make a transition from n equals to 4 to n equals to 3. So everything that falls back to the ground level n equals to 3, it belongs to Paschen series. Okay, and then we have a second example questions. In this case, calculate the wavelength of the third line in Bohr'S series. So can I know Bohr'S series, what is the ground state?
2.
2.
Okay, and 2 equals to 2, or your final energy equals to 2, or the ground state equals to 2. Okay, so third line in Bohr'S series, what is the transition?
2.
What is the transition? So when we talk about the transition to form this line, so perkataan line ini kena highlight kan when you talk about third line, second line, it must involve two energy level. So from which n to which n?
5 to 2.
5 to 2. Because our first line is from 3 to 2. Second line is 4 to 2. So the third line will be 5 to 2. Boleh rujuk balik awak punya energy level diagram yang ini. Kalau kita tukarlah yang inilah n equals to 2 kan. So first line from 3 to 2. Second line will be from 4 to 2. Third line will be from 5 to 2. So mesti kena indicate first. You need to identify the transitions first. Okay, so dekat sini kita ulang balik tadi yang kita apply formula kan. Wavelength, lepas tu ada energy level, 1 and the energy level 2 over here, then which formula are we going to apply for these questions?
Formula yang
1 over lambda.
1 over lambda.
1 over lambda equals to Rybert constant.
RH
And then over here, remember, our value of
N
N1 and 2 must be written, yeah? So wavelength must be greater than 0, N2 must be bigger than N1. So dekat sini ada dua nombor saja kan awak letak N2 adalah 5, N1 adalah 2. Tak kisah siapa initial final. You just compare the values only. Then you apply it. 1.097, 10 to the power of 7. Then you apply it over here. 2 square minus 5 square. So try to calculate now to see whether the answer given is any mistake or not. Yang ini mesti kena tulis yang madam highlight dekat sini. Transition dari mana ke mana mesti kena tulis. Untuk soalan macam ni. Kalau dia tak ada specific energy level yang mana satu, you must write down. The third line forms when the electron makes transitions from n equals to 5 to n equals to 2. So you want to make a sentence can, you want to show the transition straight away also can. As long as I can see the values of n.
Teacher, jawapan dia 4.34. 4.341.
Before that, for this one, before you
Tiga.
turn. Jangan lupa untuk sini.
Before change.
For this value, it's given in the in the notes, right? You try to calculate whether it's the same or different.
Same.
Same, yeah? Okay.
Same.
So your final answer, since the question didn't request in nanometer or meter or whatever, you can just leave your answer in meter. Sebab soalan tak minta. So sebenarnya awak boleh terus tinggalkan dia dalam meter. Nak tukar dalam nanometer tak ada masalah juga. Sebab soalan ni tak ada mention. So you can choose either you want to stop your answer in meter or you can convert into nanometer. Unless the question stated. Is that alright?
Alright. It's okay.
Okay, so almost there, yeah? So our exercise over here, we have 1, 2, 3, 4 questions. I want you to try all of this. Okay, question 1 until question 4. And there will be some presentations on Tuesday. So nanti madam tengok dulu senarai nama. Saya akan update dalam awak punya practicum. Tengok sama ada buat dalam kumpulan, secara kumpulan presentation or individual presentation. Okay, question 1, 2, 3, 4. Okay, all of these questions. So sama juga dalam awak punya Google Classroom, submissions of exercise of these 4 questions. Okay, so untuk GC submissions, due date will be tomorrow at midnight. Untuk formatted assessment, tak ada tapi madam nak buat sesuatu dekat sini. So we have another 10 more minutes over here. So we want to do a little bit of quizzy. So madam share link dalam awak punya what do you call the Telegram, and then I'll wait you to join in. Let me share first. To answer some questions, very simple. In one more class, which is MS8. Are you able to join in?
Yes, madam.
Yes.
So either you key in the game code or you click in the share link, yeah? Do I need to start first or you join in first? Madam belum tak pernah try lagi Quizzy.
Kita orang kena jawab sekali ke, madam?
Mm-mm.
Oh, okay.
Dah join ke?
Dah, madam.
Apa tak ni lagi?
Madam, ni live quizzes ke?
Oh, madam planning nak buat live. So I'm trying first. So
Sebab saya
what should
tak
I
dapat
do?
masuk lagi.
Tak dapat masuk lagi. Oh, I can see it now. There are 71 of you. Nampak, yeah. Okay, so everyone ready?
Yes, madam.
Let's start now, yeah? 76, 78, 79, 80. We have 99%. Another 20 missing. Okay, let's start now. Macam cepat sangat eh? Oh ya, Khairul Anwar dapat yang pertama. Postulate. Ramai yang jawab. Lain-lain pula. Tok. Okay. Shall we begin next questions? Is already
Yes,
ready?
madam.
Yes.
Yes, madam.
Okay.
Boleh.
Which of the formula is used for the questions below? Calculations the energy of electron and energy level n equals to 3. Leaderboard. Wait, well done. Okay, we got mostly correct answer, 82. So we say energy electron at specific energy level, we use this one. Okay. So next question, ready?
Yeah.
Ready.
Ready.
Pop. Ha. So soalan ni lebih kurang sama macam tadi kan? So kalau nak cari wavelength, which one is the most suitable one? Time's up. The three more didn't answer, yeah? Okay, so see whether most of you got it. Wow, we changed a little bit of the leaderboard. Okay, so let's look at the full questions, huh? Because we got some different answer. which is the most suitable formula to solve the question below. So the question is asking for wavelength. The best answer, the best formula is the wavelength formula. Okay, this is also helping you to answer your tutorial questions as well. So those 22, while you are choosing delta E, then you need to think about what is the questions asking. Okay, and our next questions, ready? From N5 to N3, what is the series? Eight more seconds. 3, 2, 1. Time's up. Another 7 of you have an answer. So let's see. Wow, we changed the leadership. Well done. Okay, so over here n equals to 5. Yang lain ni memang salah faham ke? Pilih saja. Main pilih je. Kalau N5 pergi N3, dia adalah bawah Postulate series. Kalau Bohr'S, ground state dia ialah apa?
2.
2. Kalau Lyman,
1.
bracket,
4.
Tiffan,
5.
5. So the other 1, 2, 3, 4, 5. So the clue of the question is n equals to 3. This is the ground state. So congratulations for those who are answering correctly. And our next question, second last. Ready? So in which series you will see colors? So only one series in those 5 you will see colors. So it's still the same, the leaderboard. And most of you got it correct. Well done. So which series is that? Bohr'S. Ground state. Ground state equals to 2. Okay, so when you see colors, you need to know that it's Bohr'S series. Ground state is equals to 2. Let's try our next questions. The last questions over here. So which transition? It means it involves 2 energy level, yeah? So third line in Lyman series. Oh, we changed a little bit. Okay. Well, here we have 2 answers which is quite similar. N equals to 3 to n equals to 1. And also n equals to 4 to n equals to 1. So if you see over here, transitions for the third line in Lyman series. So Lyman series ground state equals to 1. So the first line will be 2 to 1. First line, 2 to 1. Second line,
3 to 1.
3 to 1. The third line will be
4 to 1.
4 to 1. So those who are choosing 3 to 1, remember, it is not the third energy level, it's the third line. When you say about line, it involves 2 energy level. So 3 to 1 is the second line. The third line will be from 4 to 1. Okay, So that's it for our, I think so, 6 questions only. Yeah, we're finished about this one. So Madam will record your result from here. Where should I record? Yeah. End the session. So I have to download, spin the wheel, draw your screen. Sorry, I'm at the first time drawing this one, but never mind. Let me hold on this one. And we go back to the exercise. So reminder once again, for today, there's no column for formative assessment. You have done that one just now. Okay. And then for the exercise, there's only one column to be submitted in your Google Classroom, which is due tomorrow midnight. And then presentation, Madam will tell you the name, and everyone should get prepared lah for Tuesday morning. All right.
Okay.
Alright, madam.
All right. Sorry for some technical problems over here. Yeah. So for anyone who want to ask questions, or you want to rewatch back the recording, Madam will share you the recording later on. Okay. After they is done the process lah. So that's all for today. I will see you on next Tuesday.
Thank you, teacher.
Thank you, madam.
Thank you, madam.
Thank you.
Thank you, madam.
Madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Madam,
Yeah.
can I ask a question?
Yes.
If the transition of the electron from the 5th energy level to 2nd energy level,
Mm-hmm.
so the ground state is the 2nd energy level, right?
Yes, correct.
So that ground state is considered as N2 or N1?
So if you fall to n equals to 2, the ground state is n equals to 2.
Yes. But the what do we call it? Like the N2 or N1 tu?
Kalau final adalah n2.
Oh, N2
Mm.
But yang dia punya jalan kerja for question tu kat sini dia kata yang 2 tu N1.
Okay, soalan 2 tu nak kira apa? Nak kira energy difference delta E ke dia nak wavelength?
Dia nak wavelength.
Kalau wavelength, kita tak kisah dia dari mana ke mana. Tak kisah dia ground state apa. Sebab kalau 1 over lambda requirement, N2 dia mesti lagi besar daripada N1. So dia tak kisah N2 mana satu, N1 mana satu. Yang penting N2 value dia mesti lagi besar.
Oh, okay.
Okay?
Okay, thank you.
Alright, thank you.
Madam,
Yes.
think, yeah. So suppose we have a hydrogen atom, right? And then when the hydrogen atom absorb some energy,
Mm-hmm.
then the hydrogen atom will re-emit the energy, right?
Re-emit, what do you mean by re-emit?
Means that it absorbs some kind of energy, then it will emit it again.
So the process is like this. It absorbs energy already, right? So it excited to higher energy level. So
Mhm.
at this higher energy level, it becomes unstable. So whatever it absorbs, when it fall down, it will release.
Okay.
So you're using re-emit is correct lah, but it only emits one time.
Yeah. So if it absorbs like red light, so it will emit red light lah. Exactly the same. same thing,
Yes,
right?
kind of this.
Oh, so the energy will not drop lah during this process.
No.
Okay. Thank you, madam.
All right, no problem. Is there any questions?
No more. Thank you.
Okay, so I'm going to end the session, sir.